Alright, last time I had said that there was a formula for each situation involving combinations and permutations. We have formulas for permutations with replacement and formulas for without replacement. This particular situation, 1A, was arranging the letters SUN without replacement, meaning each letter could only be selected once. And these are all the different permutations of it. So with permutations, order matters, and we said that there would be 6 different permutations here, and that it followed the formula of NPR, where N is the number of objects that you're choosing from, R is the number of them that you're choosing. So in this particular situation, the right thing to put into the calculator would be 3p3, which came out to be 6. Down here, they're asking for combinations of the same letters, and we said that even though these are all in different orders, they are actually the same combination because the same objects or letters are involved. And the formula for that without replacement would be NCR, and that would be 3C3 on calculator, and that turns out to be 1. Alright, so let's try 1C and 1D. This time replacement is allowed though. And then I'm also going to bring up the formula sheets so that we can get the formulas that go with that. This page shows all the different formulas that go with this situation. This is the formula for permutations with replacement. So let's write that down. N to the R. That is permutations with replacement. Then when we're doing combinations with replacement, we want this one right here. N plus R minus 1 CR. I'll let you try it. Try to plug in what you think should be plugged in here based on, what N and R would be for 1C and D. Okay, what do we think N is for 1C? It is 2. Yes, there are 2 objects being selected from. What is R? It is also 2. Yeah, because we're picking 2 of them. Our final permutations have 2 objects in them each, so R is 2. How many permutations are appearing there? Like, what is the answer to 1C as far as how many different permutations we have? 4 different permutations. TF and FT are in a different order, even though they're the same objects. So our final answer should be 4, and we want the formula to give us that answer. And so it would give us that answer, right? Because we would do 2 to the 2, N to the R, which is 4. So it matches up with what we think it should be. So down here, we want to do a little bit more complicated formula. How many different combinations are shown there? That's a tough one. Yeah, 3 is right. TF and FT are the same combination. They use the same elements, just in a different order. So that's one combination. TT is a different combination because you don't have an F there, you do there, so it's different. And then FF, of course, is different as well. That's 3 combinations. We want the formula to be able to give us that answer. So we got n plus r minus 1 cr is how we have to enter it. So what do we write? We again want n to be 2 and r to be 2. So we want 2 plus 2 minus 1 C2. Alright, let's go to calculator and enter that. Now we showed how to enter permutations and combinations last time using the math button on the TI-84. So let's hit math and then probability. We'll do NCR. And now, because I have the TI-84 plus CE calculator, I can type my formula right into this spot. I can enter it exactly as it appears on the page. Now, if you don't have the CE model, then you won't be able to enter it exactly like that. It does give me the right answer, of course, which is 3. Let's try this one. How many different permutations of the letters LOL are shown there? It's supposed to be 3. How many different combinations of the letters replacement allowed is shown here? I'm going to circle all the ones that are unique. OOO is definitely unique. LLL is definitely unique. But here I see that there are several examples of having 2 L's. These are all really the same combination. Yeah, because 2 L's, 1 O. Then these guys are the same combination as well. So that is a total of actually 4 different combinations. Alright, so here's another example of combination lock. Is a lock a device that uses with replacement or without replacement when it comes to the numbers, the digits that can be part of the combination? Yeah, it's with replacement, right? You can even see it in the picture. There's 0 is being selected over and over again. So this is with replacement. The digits being, of course, 0 through 9. Does the order matter when it comes to a combination lock? Like if you go to open it, could you put in the combination 1, 2, 3, 4, 5, and then also open the lock with 5, 4, 3, 2, 1? Would it open either way? It has to be in a particular order. So order matters. Now, we should come up with an N and an R. What is the N and what is the R? N is the number of objects being chosen from. So N is 10, N is 10 actually, yeah. It's the digits 0 through 9. Those are the objects that you're choosing from. And then R is what? Yeah, 5, good. Because you're going to pick 5 different ones. Okay, cool. How many different possibilities are there for the final number? 10 to the power of 5. We got to do that on calculator. It's 100,000 possibilities. And is it a permutation lock or a combination lock? It is a permutation lock, actually. All right, so let's go over each of these. So the first one says that digits 1 through 6 are going to be placed in a hat. I'll draw the hat. And in the hat, we've got pieces of paper with the digits written on them. You're going to reach in one at a time, pull them out, and then create a number out of that. They're randomly selected. This is without replacement, though, because it didn't mention putting the numbers back in the hat after you pull them out. So an example of an outcome you might get could be 4, 2, 3, 5, 6, 1. So, what is the n for this situation? It's the number of objects that you're picking from. That is 6 different letters, 6 objects, so n is 6. We're also going to pull all of them out, so that's a r of 6. So since the n is 6 and the r is 6, we can now go on to the next step, which is plugging into the formula for without replacement. So we want to do 6p6 on calculator. I'm going to go to the math button, go to probability, NPR. 6p6 turns out to be 720 different permutations are possible. Alright. Now they're talking about the letters LOVE. And that's going to be an N of 4 and a R of 4 because 4 letters are going to be selected. But the formula for permutations with replacement is different from the formula for permutations without. So we want 4 raised to the 4, which turns out to be 256. Now they're saying, what if you do it again but without replacement of the letters? Now you don't really ever have to use this version of the formula with the factorial, that's the exclamation mark, because your calculator can just calculate it. But that formula just shows how the calculator is doing it. And I'll just give an example of that in this 4b. So formula is NPR. We want 4p4 for this one. NPR can be calculated as n factorial over n minus r factorial. We got to plug in the n and the r, and we would get that. Then a factorial means to start with the original number and then multiply by the next preceding numbers one at a time. So 4 factorial means to do 4 times 3 times 2 times 1 until you get to 1. Now down below we would have 0 factorial. 0 factorial has been defined in math as just 1. So the answer is going to be 4 times 3 times 2 times 1 over 1, which turns out to be 24. So we want our calculator to tell us 24 as well. 4p4 comes out to 24. There's also a factorial button on your calculator. If I go to probability, choice 4. Choice 4 is the factorial, so you can get 24 that way as well. But like I said, you don't really have to ever use the factorial because we have the P and C buttons on the calculator. Okay, next. What if we take from 4 letters and choose 2 of them with replacement? How many different permutations could we make using those letters? So we have 2 blanks. And there are 4 ways for the first letter to be selected. And there are 4 ways for the next letter to be selected too. Could be LOVE because replacement's allowed. So this is the formula, n to the r. And so n is going to be 4. And then r is the number of objects we're selecting. So the answer to this one would be 16. Let's see, next. What if we don't replace them? Well, the way that would work is now you got 2 blanks to fill out. You got 4 ways that the first blank can be filled. 1 letter is gone now after that blank is filled. And so there would only be 3 choices left. And so the formula that takes care of that is NPR. You can see maybe why it works, right? Because you got n factorial over n minus r factorial. So it's going to be 4 times 3 times 2 times 1 on top. But on bottom, you do 4 minus 2 and you get 2 factorial, so you divide by that. What ends up happening is those cancel off, see? And that's how the formula calculates what the different possibilities are. And it really does come up with the 4 times 3 in the end. So it's going to be 12, apparently. We want to do 4, pick 2. There we go, 12. Alright, next it asks about combinations. How many different combinations of size 2 could be made using the letters? Now, if it's without replacement, the formula sheets say to do just NCR. So that'll be 4, choose 2. Let's try that. I get 6. And that's small enough that we could actually list what they would all be. It would be, I guess, LO, LV, LE, and then you could have O with V, or O with E, or V with E. That's all the possibilities. There's no other possibilities. So it is 6. Alright, you wish to select 3 cards with replacement from a 52 card deck. Use the permutation formula to find out how many different ways the cards can be selected with replacement. Alright. Formula for with replacement is n to the r. So we would want, it looks like 52 to the power of 3. You got 52 cards to pick from. They're all unique. And we're going to pick 3 of them. So I would have that. 140,608. Use the permutation formula to decide how many different ways can the cards be chosen if it's without replacement. Well, then we want NPR. So we want 52 permutation 3. I get 132,600. So not surprisingly, if you replace, you get more possible permutations. If you don't replace, you get less.